Welcome everyone in our session on how ethics will help us design and build the so-called RegTech, and which is essentially technology that will help us control technology. I'm very happy and very proud about today because this is the first webinar that we at Code for Thought organize on our own, not within the context of an event or like we did in last March with MozFest. So this is something we organize by ourselves, and we have some really nice guest speakers from Ethical Intelligence who may need some time in order to join because they had another meeting prior our session. What we're going to discuss today. So from my side, I won't say much. The floor will be given to Panos and Andreas to present you in detail what we are doing at Code for Thought. But today we're going to discuss about how ethics and technology are joining forces, how by using ethical principles we can design systems and technologies that will help us control mainly and essentially AI systems, because what we are witnessing already in business and in society in general is that this is the main theme of today's webinar, is how ethical principles that Olivia and Fiona here colleague know way better than us are affecting or are being the basis for as requirements for us engineers and technologies who want to build technology that will help us control AI. The technology we're building at Code for Thought is called Pythia. And what we are doing, the philosophy behind it will be explained by Andreas. Panos will give you also a demo of Pythia, and now I'll give the floor a little bit to Olivia to tell a little bit about herself. Then we make a round with introductions, and then we will start. Olivia.
Thanks, Yanis. And I have to apologize on behalf of my colleague, Fiona. She is based up in Helsinki and went out painting last night. This all sounds very strange, but she went out painting last night and is not feeling well today. Turns out if you paint until midnight in Helsinki, you do come down with a cold. So it's a very funny story, but apologies on behalf of my colleague. You'll just have me today. But I'm Olivia Gamblin. I'm an AI ethicist and I run Ethical Intelligence. We're an AI ethics advisory firm, and I'm very excited to talk to you today about specifically fairness and transparency, those ethical principles. But that should be good for an intro, I think.
Okay, thank you very much, Olivia. Andrea, would you like to say a couple of things about yourself and then pass the ball to Panos?
Yeah, sure. Hi, everyone. I'm Andreas, and I work on Code for Thought as a machine learning engineer. And besides machine learning, I also research on transparency and more precisely on explainability methods. And we have here in Code for Thought, we have created our own content method called Mashup, which we'll show you later in the demo.
Hello, everyone, and thank you for your participation. My name is Panos Papagiannopoulos. I work as a software engineer at Code for Thought, and at the same time, I'm a fairness researcher and completing my master thesis in bias mitigation. I combine them both in my day-to-day job, and today I'm going to demonstrate you a use case that we have worked on and used Pythia in order to make our work more clear to the audience and give a better insight on what we are doing.
Okay, thank you, Panos. Everyone, as I said, this session is being recorded because we would like to broadcast it later via our own website. And if Olivia wants and agrees, they can also share it from Ethical Intelligence website. One thing, we would like this session to be as interactive as possible. So You can either interrupt and ask questions, raise your hand, and I'll make sure that you will be given space and time to ask your question, or you can ask your questions in the chat section of on the right corner, and then I'll make sure that your questions will be asked and responded. So I think we'll start with Olivia, right? The ethicist in our group who sets the foundation. Olivia, go ahead.
Yes, thank you, Yannis, and happy to be here today to give a little bit of background on the ethical principles, kind of the core ethical principles. So I wanted to start with a conversation of just asking, and I always love doing this, and thankfully we've got a chat function on Zoom, but I like to ask, what do you define, how do you define ethics? What is ethics? You hear that term, what do you think? So you can either unmute yourself or enter into the chat, but I like to hear what people come into a conversation with, what kind of preconceived notions of ethics are they functioning with? So I'll watch the chat, but.
You understand that you ask Greeks about ethics, right? So we have an unfair,
yes.
we have an unfair advantage.
This is true. This is true. So you guys should have really good answers then.
Yeah, exactly. The stakes are high.
Hello. Can you hear me?
Yes.
Yes.
I think, yeah, as Yannis said, that ethics is origin is from Greek, ancient Greek, and the term, indeed, as mostly all the terms in science are originated from Greek. So you have to be proud of that. In ethics, so what we mean is that is beyond what a moral principle is more like, for example, when you want to operate within a system of, I don't know, machine learning, as you mentioned, then you have to go through what are the problems that we have to deal with. For example, if we are getting the data from, I would say, from a group of people, then they represent different backgrounds, which means that each and every background should be securely, I would say, preserved. Like, for example, no disclosure of information. And this is the first part that ethics should be, and also legal in some states, like in some countries, in developing countries. So I think ethics is also about being the first part, because if you do not, for each and every project, if you do not start with ethics, I think that it is mostly like you will be destroying your project in the other steps. So ethics is the first step to design a project, in my opinion.
Amazing. Well, yes, that's usually what I say as well. So you took that already, but that's fantastic. Thank you. A few other answers we've got in here is it's our moral compass, possibly the set of inherent or converging societal, implicit or explicit rules that govern life and action. I have to say, this has definitely been the most robust answers I've ever gotten to this question. So it is good that I asked a room of Greeks. Normally, the kind of answers that come to this question are like, oh, well, it decides who runs over, who gets run over with the self-driving car, and sometimes I'll get the answer of, oh, it's subjective things that everyone puts their own opinion in. Of course, you guys, it seems like you guys already have a strong understanding of ethics from the ancient Greek philosophy background that I'm sure you all have, which is great. This is actually very fun for me. Usually how I start and describe it is ethics is the study of right and wrong. I'm really simplifying this down, of course. I'm really simplifying that central idea down to it's the study of right and wrong, the nuances that exist within that. And really, we're looking at right and wrong based off of these ethical principles. Another way that I will define it, especially when working with clients and in the business world, we'll say in industry, is ethics itself. And you all will probably be familiar in hearing this. Ethics itself is the pursuit of the good life, whatever that good life is. And here we're looking at the good life being a beneficial one where the well-being of the person and the dignity of the person at the end of the day is respected. Ethics is a tool to reach that end goal. What I mean by this in industry ethics, these ethical principles, are tools to help us realize the best possible version of our technology and of our applications in tech. So we're looking at how do we best design our technology to reach and uphold the well-being and dignity of the people at the end of the day. The pursuit of the good life will say the best possible technology. Ethics is a tool. The ethical principles are tools to get us there. Which oftentimes people hear that and they go, oh, but ethics is more of this negative thing. There's that negative connotation generally when people speak on ethics. It's, oh, well, it tells me that I'm a bad person. It tells me that I'm wrong. All of these things, there can be that aversion to it right away. It's not entirely false. It's not entirely true either. The thing with ethics, there's something built in there called moral growth. And what moral growth means is as you make decisions and you see the consequences and you see the impacts of those decisions, you then revise your understanding. You go back and you reflect and you say, okay, that decision that I made didn't come out with the best possible results. I need to learn, reflect, I need to go back, I need to fix my actions, I need to improve, and I grow and I move forward. So when it comes to using ethics, if you run across a point where you're like, oh, that wasn't quite right, it doesn't mean you're a bad person. If you're going back and you're fixing and you're taking responsibility for your actions, that's actually a very good thing. It's naturally how we learn as people, how we learn as humans, how we grow morally, is by making mistakes, recognizing them, and growing from there. So I wanted to take that down that wall real quick when there's that fear of, oh, I did something wrong, I'm a bad person. We're talking about ethics, I'm going to hear that I'm a bad person. That is not true at all. We're using ethics as a tool. And a tool both in risk mitigation, this is why it's so important, again, in business. It's a fantastic tool for risk mitigation. Irvin, I think I'm reading your name off of your title, but Irvin, one of the things Irvin brought up is if you're not building in these ethics by design, it's a common way we call it, but ethics by design. If you're not bringing in these ethical considerations from day one, what you're doing is you're creating ethical debt as you keep going. Just as you can create technical debt, there's something called ethical debt. You have technical pieces, you have technical holes, you're making those split decisions. Eventually they're going to come back and not bite you, but they'll come back, they'll become issues. Your whole tech can fall apart. Same with the ethics side to it. If you're not building it in from day one, you are building think of it like a house without its main pillars. You're building a house without its main pillars if you're not bringing in ethics from day one. So it's a very important aspect. It's also used in the direction of innovation. You can design features of your technology around ethical principles and push your creativity in that way. So really, what I'm doing here is pitching ethics as a tool. It is a fantastic tool for your business, for your company. It's that risk mitigation. It's making sure that you are fully aware of what your technology is capable of, and you have the right guards in place to make sure that you don't end up with a dumpster fire in doomsday. Something's gone terribly wrong, but you didn't predict. You've had the foresight to look into, this is exactly what my technology is capable of. Here are the harms it can cause, and here's how I'm going to prevent that from happening. But also in the opposite direction. Remember, we're working towards the good life. Being able to understand this is really what my technology is capable of, not just in terms of pattern matching and having quick turnarounds, but this is what my technology is capable of in bringing benefits to its users, to my clients. In that direction, ethics can help us push in that direction. So now I want to go into the two main principles that we're going to talk about, fairness and transparency. And I want to do the same thing again. How do you define fairness? We're going to start there.
Hello?
Go again,
yeah.
yes.
So is the same term with equality. Like, for example, if you have, let us say, a group of people, then you want to treat them equally. The information that you get from them, is like, even in softwares, when you want to design an application, then when you design ethically, as you mentioned previously, is like you want to make all ages included, for example, equal access, let us say, or without taking consideration the geography, or without taking consideration politics, or like everybody without the race, political thoughts, or something like similar like this, you know, equal access. And about the transparency is like a disclosure, which I mentioned, I think in the beginning, where I said about when you want to be trustworthy as a company, I think that you need to be transparent with your clients. So it is a basis, I think.
Irvin, do you come from a philosophical background?
It's kind of similar.
I can tell. Anyone else want to have a go at the definition of what fairness is? Thank you, George. Fairness could be about removing unwanted bias from a decision-making process or an action. Exactly. So I want to go into and unpack this a little bit more in terms of what is unwanted bias, what is fairness. Oftentimes you're going to see fairness and bias equally represented in terms of research, in terms of just articles, basic articles talking about, oh, we need fair algorithms. That means we need to remove the bias. So let's start with the fact that it is impossible to remove all bias. We need some type of bias. There's some type of bias in the sense of we're looking for a certain profile for different reasons, or there's even things called ethical bias. When you're making a decision, when you're choosing one thing over another, that's a type of bias at the very end of the day. What we're looking to remove is the unwanted bias, and the heavy emphasis on unwanted bias. And what that means is, and this is going to the term of fairness, bias, unwanted bias, negative bias, you can also call it prejudice, is when decisions are being made off of demographics, off of aspects of a person that are outside of that person's control. For example, I have no control that I was born white and female. I don't have control over that. And so if a decision is made for me based off of the fact that I am white and female, those things out of my control, then that is an unfair bias. It's not within my control. I do have control if whether or not my hair is long or short. That's a terrible example, but whether or not my hair is long or short. And if a decision is based off of I have long hair, well, I still have control over the fact that I can change the length of my hair if I want a different decision. That is a type of bias, but it's not as strong as one where it's made off of an aspect, a demographic about me that is outside of my control. And this is where fairness comes in. Fairness, when a decision is based off of an aspect that's outside of your control, that is unfair. We perceive that as unfair because we cannot change it. There's no way that we have any agency, no ability to change the decision made on us. And so that creates this feeling of, well, that's unfair. There is no other reason that, let's say Panos was chosen over Olivia, me, except for the fact that Panos is male and Olivia is female. There's no other reason. Well, then that is seen as unfair. Those are aspects about Panos and myself that are outside of our control and that don't have any impact on the decision itself. So this is why it's really important to understand the difference between bias in general and unwanted bias. You have to really sit and ask yourself, okay, what decisions are being made off of aspects or indicators of people that are outside of their control and that really have no impact on the actual final decision. Now, in that case, let's also push this in a different direction. The context is very important. For example, if the decision if the decision being made between Panos and myself, who would be better at giving birth, I can say that I will be better at giving birth than Panos for very obvious reasons. But the whole decision that's being made is something that is connected to whatever organs we have inside of our bodies. Yes, it's out of our control, but it's connected. The context is connected to something important about us. But again, if it was who's better fit at the job, and the algorithm or the decision is, oh, it's Panos solely because he's male, that's unfair. That creates this sense of injustice. And fairness is very important besides just the intrinsic need of wanting to have that equality throughout people. When it comes to your technology, if you have the bias, the unwanted bias built into your systems, if it's not fair to your users, if these decisions that your algorithms make are not fair towards your users, that creates this feeling that justice hasn't been served, that there is a problem with your system. And you will see flashback. You will see your users either not using your technology, period, avoiding your company. That's the best case scenario. Worst case scenario, you have huge risk of reputational damage. You see, for example, companies that have any type of bias, that use HR hiring software that is biased towards a certain demographic, that then feeds back to the company. There's reputation damage to that company that they have used that kind of hiring software, and then they're not getting in the best possible, they're not getting in the top applicants to their jobs. It feeds back in that way. So in best case scenario, when you have an unfair system, when you have not considered fairness from day one, you have your customers, your clients refusing to use your technology or refusing to engage with your company. Worst case scenario, you're actually hitting news lines and having catastrophic implications for your company. And in some cases, there are companies that go under because of that. So that's fairness. Now, I want to turn to transparency. Again, let's think of these as tools. Fairness is a tool, a way to consider things. When we want our technology to be fair, when we want our technology to be the best possible technology, pursue the good life, we want it to be fair. We want to be able to analyze what is the unwanted bias that is capable in the system, and how do we balance the scale so that it's fair again. So transparency, I'm going to ask again, how do you define transparency? What is transparency as a tool? Being explicit about how decisions were made. Yes, great point. So I'll dive into transparency now. If you still have definitions that you want to add, please do. I love the interaction and the building this all together and our understanding. So transparency is a very powerful tool, again, when it comes to ethics. Think of transparency as an ethics enabler. So by being transparent about the decisions that were made, just as I'm sorry, I'm going to probably mispronounce your name, but Danielle, I hope. I mispronounce names all the time, so I do apologize. But being explicit about how decisions were made, that is being transparent. That's the act of being transparent. If those decisions were made based off of ethical principles, if they were made with thought and care, you no worries about the microphone, but then you have enabled your clients, you've enabled your stakeholders to see the ethics that you're bringing into those decisions. If you are explicit and there have been poor decisions, or maybe not well thought out ones, or ones made off of even unethical decisions. If you're transparent about unethical decisions, first of all, that's usually not what people are. They usually try and hide those decisions, but it's also still revealing, again, see-through decision-making. Exactly. It's showing we do consider ethics. We do build ethics into our decision-making. We do build thought and consideration into our decision-making versus this was made for different reasons that maybe didn't have the best of intentions. So transparency can be this ethics enabler, as in showing your clientele and your stakeholders, look, this is good decision making. It is well-founded decision making. Transparency is also an interesting element in the sense that you can have too much. So think of it this way: if I come in, I'm like, I'm going to be completely transparent about all data that I ever collect. Completely transparent, open source, everyone can see it. That works great if I run a social media company. I'm showing, hey, I'm collecting all this data on you, and this is what that data is contributing to. This is who it's being sent off to. All is good. I'm being transparent in that sense. I am respecting your rights as a user to know where your data is going. Now let's change the context. Say I run a medical center, and I'm completely transparent about all of the data that I'm collecting and who it's going to and what decisions are being made off of people. That is a completely different context. Extreme transparency in that context is not good. at that point, I start to compromise the security and the safety of my users. Because as I open up, I'm transparent of, yeah, I collect your heart rate, and I collect your blood pressure, and I collect your blood type and everything. What that does is it starts to open you up for cybersecurity risks. So in some cases, such as with health data or financial data, securing, yes, Irvin, securing privacy of clients' data, securing that security, that cybersecurity element. Transparency, too much transparency in that case is a bad thing. So you're walking a line in terms of transparency. You want to keep secure and private the important elements, the risky elements, let's say, to your clients, but you want to be transparent about your decision making. You want to be transparent about what values your company is upholding. A great way to think about this is, let's say you're hosting a banquet. You don't necessarily need to reveal every single ingredient that was used in every single dish. You do need to be transparent, though, about any allergens. So any type of allergies that people may have at the banquet, you want to say, okay, here are the allergies that may come up, or here are the let's say you have vegetarians coming. This dish has meat in it. You do need to be transparent about those aspects. You don't necessarily have to be transparent about every single detail. With that as well, what can happen if you are overusing transparency, if you're overzealous and you're communicating everything and it's out of context, that's again useless to your users. If I come to a banquet and you tell me every single ingredient, I'm going to get lost in terms of, okay, but what dish has what ingredient in it? And why do I need to know all these? It's very confusing, and there's this overload of information. I'm still not getting the core of what I needed. I need to know if I'm going to have any allergies to any of these dishes. So transparency, although a great tool, needs to be used within context, and you need to give the context of that transparency. So you can't just say, we collect your heart rate. Why do you collect my heart rate? What's that context? Why are you collecting it? What is it used for? That is, giving that context around that is so important for your stakeholders.
Olivia, if I can interrupt you, you're
yes.
doing great. Believe me, you're doing great, because you are just pouring out very good ideas. And just to add something, to say in other words, what you're saying in the last words is that while using the context, the data is that, for example, we have seen companies mostly in US, when they invite, not, I would say middle-sized, not the corporates, just middle-sized companies, when they invite their customers, their most frequent customers, and they invite in their board, in their decision making, which makes them more, more exposed to the general audience. So I think it is one principle that that belongs to what you said before. And also, when you said in the last word that it is also the consent of the customer that also matters, which means that if you are not, if you are building a software, let's say, and if you are not getting the consent for the information from that customer, then forget it to go further, because you will not be allowed. So I think this is the point. Thank you.
Absolutely, Irvin. And just as to highlight actually as well, this brings up a great point. A lot of these ethical principles are connected. One enables the next, enables the next. Consent starts to come in, which gives your users agency over their data, and privacy as well. Being transparent about that consent, being transparent about different principles that you're using. It's all connected, and it is especially connected to the context of your technology. So you need to analyze the context in which you're creating that technology. Thank you, George, as well. Not overwhelming info point, because information effectively obscures things and reduces the ability to understand, explain decisions. Absolutely, there is that over communication. So I'm going to kind of summarize this real quick and hand it back over to Yanis and Panos. Thank you for interacting with me as well, everyone. I really enjoyed this back and forth. As a philosopher and as a philosopher speaking to a virtual room full of Greeks, this has been fantastic for me as well. I've really enjoyed this. But just to summarize, fairness and transparency are two of the ethical principles that can be used as tools. There are two. There are so many more. You've got responsibility, you've got privacy, you've got agency. There's a lot more there. Fairness and transparency are two very key ones, though, and are especially they're very key in the current market, in the current field, in the current use and development of our technology. So those are absolutely essential when it comes to building your technology from the ground up, when it comes to building it in from day one. So those are key principles to the success of your business. So I'm going to close off there, or at least end there, and hand it back over to, I believe, Yanis.
Yeah. Well, let's put a pause here because we have a presentation, but then as soon as we finish the presentation, then we have this Q&A session. We really want to make interactive, and what is happening right now, it's just great because it's very promising when it comes to our Q&A part of the session. So I'll pass the ball to Andreas to start the presentation and thanks for laying the ground for us, because we also shared that view that fairness and transparency are very essential or very valuable at this point where the market is and the maturity of AI systems in general. So let's see how we can build on that and how we can transform it into something more tangible and concrete, let's say. So that's our part for today, at least. And then we continue the discussion. Andrea, I'm making you a host so you can share your screen. And yeah, we go.
Perfect. Okay. So I guess a majority of you have some kind of social media account. And if you follow technology news in general, you probably have come across some of these recent headlines where there are described cases of algorithmic bias towards some specific groups of people. For example, in these cases here, have had bias systems from Apple and Amazon towards women. And these two big headlines here describe ethical AI issues and problems within tech giant companies like Google and Facebook. So all these facts leads to the case that this AI injustice is not a minor issue anymore, and it's not something that we talk now and will happen in the near future. It's already happening, and it's already affecting real people. And the reason behind this injustice is caused by some unexpected behavior of such systems, especially machine learning systems. Sometimes are viewed like this. So this person on the left asks, this is your machine learning system? Yep, you put the data into this big pile of linear algebra and then collect the answers from the other side. And what if the answers are wrong? Just steer the pile until they start looking right. This representation may be comic, but it's not far from the reality. Since many machine learning models behave like black boxes, which means that their inner structure is so complex that we have no idea how they make their decisions. And we need to find a way this unexpected behavior leads to this AI-driven injustice, and we need to find some ways to deal with this injustice. One way is to pray, like Pope Francis urges followers to do. Okay, that's a good first step, but here, not for thought, we have built the technology we name Pythia that ensures that AI systems can be trustworthy. And how an AI system can be trustworthy if there's no bias in it, and if there's bias, we should help mitigate it, and if we are able to explain the decision making behind the model, behind the algorithmic system. So we believe that this analysis is very important for any algorithmic system, but regardless of our opinion, there is some legal necessity and some legal basis behind this analysis. And the new AI EU regulation that came out very recently, less than a month ago, describes more concretely the necessity behind fairness, transparency, and accountability. But even before the new AI regulation, the good old GDPR described some principles of algorithmic systems, like fairness, transparency, and accountability. I'm not gonna focus here too much. If you want to read, to see more information about how these concepts are interpreted by GDPR, you could read more at our blog in our website. So there is a necessity for these principles, and lately there is also a standard how to test these AI systems for these things. So there is this ISO 29119-11 provides some guidelines for testing AI systems. These are some areas of this standard, the standard tests. But from all these areas, we mainly focus on bias and explainability because, like I said, they are linked. They have some legal basis inside them. So we do bias testing, which is again to detect if our data set, and as a result, our model has some bias in it, and explainability analysis to understand how the AI system came up with their predictions. As for the bias testing metrics, the main metrics we use are called the disparate impact ratio and the conditional demographic disparity. And the reason behind this choice is, first of all, because they have some legal basis behind them. This disparate impact ratio is linked with the 4/5 rule that is issued by the Equal Employment Opportunity Commission of the US Congress. We'll talk about a little bit more about this rule later. And the conditional demographic disparity is considered by many lawyers and law researchers as the most suitable and the closest metric to Europe's indirect discrimination law. Second reason is that these metrics do not require the ground truth. We just need the selection rates from the predictions of different groups of people. And third reason is that they also have some thresholds in their definition. So the disparate impact ratio, a value for this particular impact ratio below 0.8 is unacceptable. And for the conditional demographic disparity, if it's a positive number, it's okay. If it's a negative number, it's not okay. So this helps that there is also a threshold to try for automating these measurements. And as for the explainability analysis techniques, there are various methods. If the model is transparent, there is no need for explainability technique. It's already explainable. But if it's a opaque model, like deep learning or ensemble models, there are various methods. We mainly use MASAP, which is our own method. We'll talk later a bit more about this method, which uses local and global explanations, and it's model agnostic, which means that it doesn't require access to the original model. And it outputs feature summary explanations. We will see an example later in the demo. So our approach is non-intrusive and model agnostic because we just need the input and the output of an algorithmic system. And we take these two things and have them as input in Pythia, in our technology, and do bias testing, explainability analysis, and accountability check. Now let's see all of this through a use case. Last September, this Twitter user made this, let's say, experiment, this horrible experiment, as he says. So he took these two images containing in the top Mitch McConnell, a white person, in the middle some white background, and at the bottom Barack Obama, a black person, and he tweeted them. And the Twitter's preview algorithm in both cases selected the white person, Mitch McConnell. And this tweet went viral. It had like 200,000 likes, 62,000 retweets, 1,000 retweets, and sparked controversy amongst the users, who tried to do their own kind of experiments. They tried to invert the colors of Barack Obama and Mitch McConnell. They tried the experiment on black and white Michael Jackson, on black and white dogs, even Lenny and Carl from the Simpsons. And the official reply from Twitter was that they tested their model before shipping their model and didn't find any bias. So as code for thought, we thought that we should make an analysis on this issue, because Twitter is an algorithmic system that plays an important role and can crucially affect real people, since it is used by world leaders to common people. And so we thought it's a perfect fit for our technology, because as I said, we don't actually need the Twitter's preview algorithm. We just need some input which we can create, and some output which can get from Twitter. So using our Pythia technology, we want to investigate if Twitter's model is truly bias-free, as they suggest, and if there is any bias, we want to understand the reasons behind it. So this is an overview of our methodology. We use the dataset containing different racial groups of images of different racial groups. We transformed this dataset. We uploaded it to Twitter. We manually labeled its image, and then did bias testing and explainability analysis. The dataset we used is called the Fair Face dataset and contains images from different groups, racial groups. But to keep things simple, we only use black and white adult males. And we created these images, these collage images, 4,009 of them, which look like this. And at the top, there is a black person, in the middle, white background, in the top, the bottom, the white person. Then we created a Twitter account, which is called Bias Tester. You can check it out. It's still there. And we tweeted all of the dataset in batches of 300 tweets per hour. And that's due to Twitter's limitations. And if Twitter selected the black person, like in this case here, we would manually like the tweet. So a liked tweet would mean that Twitter selected the black person. So we would then aggregate all of this data and take it as input to Pythia. And this graph here is the output from our bias testing analysis. So here we use the disparate impact ratio for black males, male adults. So some words about disparate impact ratio. It basically measures how differently the model behaves across different groups of people, between black male adults and white male adults. Ideally, we would like this metric to be equal to 1, which would mean that Twitter's model has the same probability to select a black male adult for its preview as the white male adult. But there is an acceptable range for its metric, which is defined by the 4/5 rule, like that I told you earlier. And this acceptable range is from 0.8 to 1.25. And as you can see, this blue line here, which represents the total fairness per batch, there are some measurements that are compliant, but the majority of them are non-compliant. And the orange line, which measures the total fairness over time, is continuously non-compliant. And after all the data set has been uploaded, it has a value of 0.63, which is below the acceptable range. And this actually means that maybe Twitter's model is discriminating against black male adults, because it's less likely that Twitter will select a black male adult to its preview photo. So now we want to understand why this happens, why Twitter does this. So we will use MASAP, which is our own explainability method. It uses surrogate models and supply values. Again, I'm not going to focus too much on this method, how it works. If you are interested, you could read these two papers that we published. And so we created another data set, which we did it like this. We took we split each collage image and individually labeled each image with yes if it was selected by Twitter and no if it wasn't selected by Twitter. So now we had double the images, so 8,018 individual images, and we had them as input to MASAP, try to understand why Twitter made these selections. Two examples of these explanations are presented here. The green pixels represent the positive contribution towards being selected by Twitter, and the red pixels represent the opposite. And we try to find, looking at these explanations, we try to find the correlation between dark-skinned pixels and negative contribution, and the light-skinned pixel with positive contribution. But we couldn't find such patterns. So we thought that maybe facial features do not play any important role in the decision making of the model, of Twitter's model. So we try to search for other features like the image properties, like contrast, sharpness, etc. So instead of having as input the images themselves, we had as input their properties, and we actually found out that sharpness had an important role in decision making. For low values of sharpness, it had a negative contribution, while for high values of sharpness, it had a positive contribution. And in other words, the majority of images that were selected by Twitter had high image sharpness. So the bottom line is, the most important question is there any discrimination in Twitter's model? And based on the data we used, our analysis suggests that Twitter does not depend on any facial feature, rather than on the total image quality, and probably on the image sharpness. But we firmly believe that any trace of unfairness towards specific groups of people should be, in any algorithmic process, should be detected, addressed, and then solved, even if the process itself doesn't contain any direct discrimination processes, like in this case. Now, some last recommendations. We suggest you to read our article in our website or our Medium account that describes this use case. And we published it in last October. And also, you can also watch this Vox's video. Vox is a journal site, a popular journal site, and has a YouTube channel, where they did a similar experiment where they uploaded images of black and white people to Twitter and see which image was selected. But I want to make a quick point here that they did it manually. So they uploaded each picture manually. Actually, they have there's a point in the video where it's a guy dragging and dropping a picture in Twitter. So I want to point out that this is why technologies and tools like Pythia is important, because they can automate and simplify this procedure and this let's say, validation analysis or fairness checks or bias testing or whatever you want to call it. And we were able also to upload 4,000 images, while they uploaded only, I think, 200 images. And if there wasn't any Twitter limitations, we could upload it even more images. So I now pass the ball to Panos, who will show you a demo, a use case through our demo.
Thank you, Andrea. Panos, we have 5 to 10 minutes most for the demo, and then we can start the discussion because there are some interesting points in the chat while Andreas was presenting about transparency and explainability. Some nice remarks from George and Olivia that these are really nice starting points. And also the conclusion of the work that we did for Twitter, the fact that the identified Twitter on the identified bias on Twitter, it wasn't related to the color of the person, but mainly on the quality of the picture. This is something also that I'd like us to elaborate and discuss, at least with Olivia. But now it's time for the demo, and then we start the discussion.
Okay, perfect. Thank you, Andreas and Yanis, for the pass. Now I'm going to guide you through our second use case. This is a demo that we have created showcasing Pythia and creating an interactive dashboard. As you can see, the user of that dashboard is an AI validator, or could be someone from the management from an organization. And for that specific demo, we have used a credit score banking dataset from a bank in Taiwan and trained it with a black box model in order to see if there is any bias on the dataset. What we have done as a first step is to check about the fairness over time, and more specifically about a prediction which the system makes. The prediction has two values, defaulter or non-defaulter. A defaulter is someone who is not going to pay his next installments, and a non-defaulter is someone who is going to pay and is considered credible from the bank. After that, we have some attributes in which we describe our data. So for that specific case, we have sex, education, and marital status, and some groups belonging to these attributes. For sex, it's female and male. For education, high school, graduate school, etc. So the first thing that a validator sees when checking his system is that the model that makes these predictions about a defaulter, a female defaulter, is biased because, as we can see here, the fairness over time is going constantly in the red area. The upper red and the lower red area are related to what Andreas mentioned earlier in the disparate impact ratio, which is what we are measuring over time, as you can see. So anything that is beyond our acceptable values, or anything that is outside of our green interval that you can see right here, which is from 0.8 to 125, is considered biased. So a validator sees that their model predicts defaulters, female defaulters, in a biased way, and certainly there is a problem with that. On the next step, he can, let's say, validate that when he or she is taking the latest snapshot. This is a tree map of the data that we have seen and represents the most recent one of them, of the bots that we have received and trained. And you can see that there are two categories again, defaulter and non-defaulter. And clearly, in the defaulter one, we have the same problem that I've mentioned earlier. There are some red areas right there. So if I click on it and drill down, I will see all the attributes, which is marriage, education, and sex. And if I click again on some of it, I can clearly see the groups that are biased and have a problem, and we need to look at them. So for example, also in education, we have some bias in graduate school, etc. And the color that we're seeing, green, is considered good, as Andreas showed you before in his example. And red means that we have a problem and we need to check it. After that, the validator has a question. Is this justifiable? Is there a reason for the bias that we're seeing? And why did the model made such predictions about its customers? And after that, he or she just needs to go to explainability analysis, which is the second thing that we are currently implementing with Pythia. And the first thing that we are seeing is the global explanation, as we call it. Well, we can see the features which are extrapolated from the customers. All these features represent the customers. And the contribution. The contribution is a percentage that says to us and showcases us how much does a feature from a specific client affects the prediction, whether he's going to be predicted a defaulter or a non-defaulter. And right now, what we can see is that the installment delay of 1 month ago, which means that the customer did not pay his last month payment, is contributing a lot. But if you keep messing around with the graph, you will see that sex is third on the list, and this is pretty uncommon for it, because in a business-wise case, this should not happen, because as Olivia mentioned earlier, sex, ethnicity, marital status, or even some other characteristics cannot be changed. You are born with them, and you just have to ignore them, or even not use them to make predictions. But right here, we are seeing that all these, sex, for example, is contributing a lot towards predicting someone as defaulter or non-defaulter. And it complements what we have seen earlier in the fairness over time tab with a defaulter and female. So after that, we have the local explanation, which is another functional requirement that we have implemented. And on this specific tab, the validator can check about specific customers. Of course, customers are anonymized. They only have an ID, and we can see their description. So for example, this customer, who is a male customer aged 38, has a local explanation tab representing him, and we can see he was predicted as a defaulter. And as you can see, again, we have these two colors, the green one and the red one. When you see the green, it means that something is positive. The negative one is represented as red. So what we are seeing here is that his installment delay 1 month ago plays a huge factor in predicting him as a defaulter. But also we can again see the problem that sex is contributing positively in that way. And that means that someone who is male has a characteristic that helps him be predicted as something else, mostly based on his gender, and this is something that we don't want. And we can also see that on the next customer, who is a female and has the same kind of characteristics, we see that the installment of the 1 month delay is contributing in a huge rate, but sex, which was previously contributing positively in predicting a male customer as a defaulter, is now contributing negatively. And again, this is the problem with the data set and how our model makes a decision. On top of that, using the MASAP technology that Andreas mentioned earlier, we can add some business value on that and give the bank or any organization the insights to help their customers. So for example, for the defaulters, we can help the bank decide if it's going to help its customers change it, how a defaulter will become a non-defaulter and be considered credible from the bank. This is what you're seeing on the last table right here. So for example, let's see for the male customer that we've seen earlier, the installment delay of 1 month ago, which has happened 2 times, can be mitigated by using the revolving credit, for example, using a credit card, and that would contribute 55% in predicting him as a non-defaulter and be considered a good client. And we have other attributes also. So for example, if he had paid 5 months earlier a bigger amount of money, he could help the system identify him as a non-defaulter. So yeah, this is pretty much what we are currently doing with Pythia. We are combining fairness and explainability in this dashboard, and each part is validating the other. So we have seen that we have some bias on the bias testing tool that is going over time, and after that we also checked on it and explained it in a way that someone who is not a scientist, for example, or an engineer can understand this. So anyone from management or an AI validator can see and understand all these characteristics that have been implemented and used by his system. So that was for me. Now Jans, my colleague, will take over. Thank you for your attention.
Okay, I think the chat is was on fire in the sense that we have questions, remarks. If you can also make me a host, I think it would be more helpful,
yes,
for
course.
me. So, okay, let's, we have 3 remarks. We have remarks from not 3, more than 3. Danielle has a, let's start with Daniele, which was having some remarks about, actually, the remark was coinciding very nicely with a demo, which is a credit card demo. The question is, and I guess it is related also with the remarks about the process and the outcome transparency that we were discussing on chat with Olivia and George. So what does it mean for a model to be transparent? So let's try to combine those remarks. So George was asking whether a transparent model is considered explainable, even if it has a series of functions and parameters. The answer is that from a legal point of view, it may be considered as explainable, but the outcome, which is the most important thing according to legislations, needs some elaboration in order to be explained. And then there is this question from Daniele on how we can share the process outcome, or how we can share the process results, sorry, or how we can share the outcome. Okay, I'd like to invite some people to, I mean, George, you can first elaborate a little bit on the question, and then Daniele can ask the question, and we can make it, we can do it real time. I mean, if your microphones are working, or we can use chat, feel free. But I will invite George in first place if he's able to talk.
Yes, of course, Yanis. So hello, everyone. I will also try to switch on my camera. So hello again. And thanks for a very interesting demo and talk so far. So, you know, having in mind some machine learning models that have millions of parameters or billions of parameters and very complex structures internally that are essentially math or linear algebra structures, as Andreas, I think, pointed out, the thing is that you can see it all and understand nothing, essentially. Effectively nothing, because you cannot, because the decision is distributed across millions of points of decision there, and you can not really explain. So the question was exactly that. How, in my mind, explainability, essentially what we are doing there is exactly this overwhelming of information that Olivia said, don't do this, right? So you say, okay, of course you can explain this, and I give you a million sentences describing why I did this, mingled together. So this makes the result not explainable at first sight. I understand, though, that utilizing tools like Pythia, you might end up identifying things that relate the input of the model to the output if you utilize the inner structure. So the question is, it was a little, let's say, weird to me that transparency is directly connected to explainability, because as I see it, as a machine learning person, let's say, it is not in general.
So I think the question is definitely around that in terms of explaining the outcome or explaining the process. And if we had no idea how a model was coming to that decision, we would understand that the outcome still. This model considers you high risk or low risk enough to get whatever credit you're applying for. But then if there is no transparency around it, how can we even be sure that those predictions are, you know, that we are making those decisions, that those scores reflect what we consider to be valid reasons for denying or accepting somebody's application? And, you know, to that end, if it's too complex to give an explanation on or to understand, should we be using that model in the first place? You know, or should we be using a model that's more easily interpreted based on decisions that have, you know, consequences for people? So if we can't get to the level of transparency of the process, is it enough to just give transparency on the outcome? I mean, they kind of know that anyway by being approved or denied. So there's not much additional transparency there. You know, yeah.
If I can take this, guys, to provide some insights on this. So first of all, and as Andreas presented, we use for our tooling, we use the ISO 29119 for testing the systems, either from a bias perspective or from explainability. There, this standard defines 3 levels of transparency. Transparency, which is the acknowledgement to the user that on what kind of algorithm or model is used for a decision and the data set that it was trained. That's one. The second is the interpretability of the model, which means that a model which is inherently transparent is considered interpretable and is easy to explain. And the third, the explainability, is the ability to give an explanation or give the reasons why a certain decision was made. with our tooling, we're focusing on the third level of the third part of transparency, let's say, which is the explainability. And there we try to do two things. The one is to provide the overall way that the model thinks, the so-called global explanation. So how the model thinks for all the data that it is receiving. And then we have the local explanation, which is the individual, the explanation concerning an individual. So you are a client of the bank. Unfortunately, your loan was rejected. The bank owes you an explanation, and they provide you the reasons why your application was rejected. But from a legislation point of view, this is what the bank is obliged to tell you, the reasons about your decision. They are not obliged to disclose you how the overall model thinks, like the global explanation, how it thinks in general for all the clients of the bank. And this is one. The second is that, and based on what Yorgo says, if a model has, let's say, 1 million parameters or 1 billion parameters, and which are more or less known, technically this renders the model non-interpretable, because no human being, without the help of any tooling, actually is able to interpret it and come up with the necessary results. So a local explanation about the client, or a global explanation of how the model thinks. Now, I hope this helps a little bit, both you and George.
Add a bit what you said, because when I said transparent, maybe there was misconcept. Transparent models in this context are models that can be explained, like linear models, where they have some factors, or shallow decision trees, which you can see a decision tree and follow the path and understand why it took this decision. So transparent models, that doesn't mean that you know the source code or the algorithm itself. It's that it's easy to understand. And so in the context of explainability, that's what transparency means.
Okay.
Of course, a deep neural network, even if you know everything, you don't understand how it works. So it's in deep neural network, it's considered an opaque model.
Yeah, these are good examples, Andrea, and they help. I don't know if Daniela, you're covered by the answers.
Hello. I just want to ask. Just want to ask about the first part when you mentioned, Yanis, about the you mentioned 3 levels, and I'm going for the first one, which I'm most interested about, is that what kind of algorithms you are using to the training of the data set. You mentioned, Andreas, if I'm correct, you mentioned about the black box and the algorithms, deep learning networks, how these things work to first of all to identify the bias, because I think this is the hardest part, and then how to mitigate it. These are two questions.
Okay. About the first one, when and transparency is just the acknowledgement. So the user or the client is informed that a decision concerning him is made by an automated algorithm, let's say. For example, the new European legislation dictates for the so-called medium risk systems like chatbots, the user should be notified that he's interacting with an automated system, not with a human being. So that constitutes transparency, let's say. The organization that operates the chatbot doesn't need to disclose any further details. I mean, what kind of algorithm is behind or how the chatbot has been trained, but they just need to acknowledge that. This is what we call transparency, at least in the narrow sense of this word, and not from a philosophical point of view, which is way broader than when Olivia explained. That's the first. About the second and the bias identification, I'll give the floor to Andreas and Panos to answer that.
Yeah, I don't understand very precisely what you meant by what models do you use we don't use any models. We have the metrics are some kind. The bias testing metrics are some kind of statistical methods, let's say, that measure do calculations on the data. And about the explainability analysis, there is other methods that, like surrogate models and sample values, we try to perturbate the data and see which feature is more important for the outcome.
Yeah, it is the same that you are saying right now is about how does, I mean, the process is about how do this data go through training and what kind of statistics you use. That is mostly about the question.
Yeah, the statistic it's based on these metrics by disparity matrixation and conditional demographic disparity, which use selection rates. So we calculate the selection rates of each group for each prediction, and yeah, there are simple ratios that we calculate automatically. We do this for each protected group.
Right. So how do you define the effect of machine learning in this system? How does it impact in your system?
Andrea, that's Erwin, this is because we need to wrap up in 2 or 3 minutes, and we have a couple of more questions. So I think we can take it, let's say, offline, and we can, yeah, you can contact us, or we can send you an email with some answers, some further answers, because we have some more questions that are coming up. Apologies for that.
No worry. No worry. It's a pleasure because you have great ideas and you're doing great so far.
Okay,
so,
thank you very much.
yeah.
Thank you very, very much. Now, the other question that was coming from George, then I have one mainly towards Olivia for the closing remark. The acceptance of a decision. This is a question from George. The acceptability of a binary decision. I guess you talk here about the acceptability of bias. In that case, we use certain thresholds like the 4/5 rule in order to be able to define whether a decision is biased or not. But if you want to elaborate a little bit, just go ahead, Yorgo.
Yes, Yanis. Okay, so very quickly, the question is, I saw that there were green places and red places.
Ah, right.
If you are very close to the border, it could be the case that you are barely, acceptable, and then you switch to acceptability like that. So, and this is also perhaps a user interface, topic, but not only that. So, if there is a regulation saying that, 4 out of 5, as you said, 4/5 is acceptable, then it's a clear case of law-based thresholding. But otherwise, I could also, set some kind of gray area saying you need to pay more attention here, right?
Right.
But as I said, this could also be simply user interface thing. So it's also a suggestion, perhaps, in cases where you do not have a very clear threshold. Thank you.
This is good. Actually, there is a legislation behind the 4/5 rule. That's why we're using it. But that suggests that threshold. But yeah, typically with thresholds, you have this with this issue with the gray areas. So when a value is very close to the threshold, what do you do there? Olivia, final question to you. So in the Twitter example that we showed, how we analyzed the algorithm of Twitter, and I'm asking you because we had lots of discussion with some friends about it. The analysis indicated that there is bias, but the bias is not is mainly related to the quality of the picture rather than the color of the person. So we can say that this is a form of course, it's an unwanted bias because it kind of somehow correlates with the darker persons, but it's a technical bias. It's not like a bias that comes to the tone of the skin. So, what is your opinion on this as an ethicist?
Okay, so if it's connected solely to the quality of the picture, then that's fine. What needs to be analyzed though is it equal across the board? So is it, are we seeing again, an unwanted bias in people with darker skin tones and quality of pictures? If there's a poor quality of, say the same quality of picture exists across a set of 10 photos, and 5 of those photos are of people with darker skin color, and 5 of those photos are people with lighter skin color. If the people with darker skin color are still scoring lower, despite the quality of the photo being poor across the board, then there's still that unwanted bias. It's also the case of, say, the people with darker skin tone, the poor quality of photo is causing them to then decrease even further in the rating. So say you've got the 5 light skin and the five darker skin, and the 5 light skin has like on a scale of 1 to 10, a 6 in terms of quality of the photo, and a person with a darker skin color has also quality of 6 in terms of quality of photo, but is scoring lower in terms of this algorithm, then there's still that unwanted bias. So it's fine if it's okay, a poor quality of the photo, but you still need to look into, are we still seeing the disparities based off of skin color or something beyond just the quality of photo? For example, I mean, it can often happen where algorithms will mark people with darker skin colors, photos of people with darker skin colors, as poorer quality, even though the quality of the photo is not actually poor quality,
right,
solely based on skin. Yeah.
So I guess what you suggest, we need to see a consistency of results, plus we need more perspective for context.
Yes, exactly.
Yes. And that's, yeah, okay, good point. Well, it's 7:34 here in Greece, so I guess 6:34 in the rest of the Europe, except Portugal and UK. Thank you very much, everyone, for attending. We have recorded the session, so we will share it via Code for Thought and Ethical Intelligence. Also, all the emails of from my Code for Thought side and Ethical Intelligence side are in the chat. So please note them down and feel free to reach us anytime. And thank you all for the participation. I think it was very lively. Especially, I'd like to thank a little bit more than the rest, Erwin and George, for the great participation, and Daniele, and for taking the courage also to talk live. We will organize these kind of things, I think, more often, because they're very nice and very interesting. Thank you all, and we'll keep in touch. And big thanks to Olivia, and pass our regards to Fiona. May she get well soon. Next time she needs to paint in Greece. The weather is much warmer for outside painting. And we'll talk. Take care, everyone. Bye.